Good morning, good afternoon, good evening, wherever you are on this planet, and welcome to our SETI Live. So today we are going to talk about comets, and specifically one comet called C 2022 E3 ZTF. Not a charming name, definitely. For this reason, we invited Ariel. Hello, Ariel.
Hi.
Ariel Graykowski, she's a postdoc at the SETI Institute. You joined the SETI Institute in June of
In
last
June,
year,
yeah.
right? Working in my group, so she has the pleasure of seeing me almost every day.
Yes.
I'm the boss, so she says it's fun, right?
It's
fun.
super fun.
It's super fun. All right, great. Starting very well. So we are going to talk about comets. Comets are basically not boring asteroids, interesting asteroids, I will say. And this comet, the new comet, has been discovered recently and is making a rare visit to Earth. So, first of all, Ariel, tell us a bit about this comet. What do we know?
Well, this comet is what we call a long period comet, as opposed to a short period comet. These are two kind of general brands of comets. And what they mean is their period, how long it takes them to go around the sun. And that's pretty broadly defined by where they come from in the solar system. And both types come from the outer solar system. So either the Kuiper belt, which is around where Neptune is and beyond, and the Oort cloud, which is much farther beyond the Kuiper belt. So the long period comets tend to be defined as originating from the Oort cloud. And so this comet is a long period comet. It comes from the Oort cloud. It comes from very, very far away. So that's one fact that we know about it right away. So when this comet comes close, like it has been, it's been very close the past few days, we can get some insights onto the materials that make up the Oort cloud, because we can't see Oort cloud objects otherwise. We have to see them in the form of comets. So it's kind of a general, what we know about this comets in general.
So this comet is coming from far away, and it's going to visit us. Is that the first time it's coming to visit us?
It's predicted that it was here about 50,000 years ago last time. It's again because that's its period. That's how long it takes for it to go around the sun. But I will give it a caveat that it is hard to measure the orbits of comets, especially these long period ones, because they interact with so many other bodies as they are orbiting into the solar system, like other planets, other comets, other Oort cloud objects, and they sublimate. And so that means they have all this ice that turns into gas, and that in itself can cause a force on the body and change its orbit. And so from what we know about its orbit before, as it was coming into the sun, it looks like it was here about 50,000 years ago. And now it either is going to take about that same time to come back, but what it actually looks like is it was perturbed. And so it probably is going to just escape the solar system altogether and not come back.
Okay, so I have some slides. Can you show the slides, please? So this is the slide showing the Oort cloud. That's what we're talking about here, right?
Yes, yeah.
So that's, we have never seen this.
Yeah, it's way too far away. We just can't see anything there unless it comes close. And that's really why we have to look at these comets when they get close.
So it's called the Oort, O-O-R-T.
Yeah, O-O-R-T, Oort.
Oort. I know that YouTube translation will not work on this one, so that's why I'm spelling it.
Oh.
Yeah. So those comets come from there. So it's basically there is a cocoon, and it's a swarm of comets, and some of them are sent toward the inner part of the solar system. So what produced that?
Well, in the early solar system, there was a lot of small bodies around in a much more dense area. Exactly what that looked like, we still, are working on that. People are still wondering, how did the early solar system form? What was all that stuff doing, and where did it go, and how did it get there? But basically, you have all this stuff, and it was crashing into each other a lot, really mixing itself up, and there was a scattering event. So there was interactions with the large planets. Probably Jupiter, which is the largest, had the most force on this scattering event, and it caused things to just fly out. And you had bodies fly out to where the Kuiper belt is and make up the Kuiper belt, which you could see on the left. It makes this sort of disk around our solar system. And then other objects got flown out even farther, and that made up the Oort cloud. And that makes up more of a spherical shell around our solar system rather than a disk, which is kind of odd. But that is one way we can identify a long period comet. Is if it's short period, it's going to be coming in from the Kuiper belt. So it's going to be on the plane of the planets. It's going to have the same sort of orbit as the planets, except a little more elongated. But a long period comet is going to come from anywhere. So it could come in from the top of the solar system, as it's viewed here anyway.
Yeah.
Top is sort of a relative term here.
All right.
Yeah.
So before we continue this conversation, we have people watching us from various places in the world. So we have people from Canada, Oklahoma, Fairfield, California, Germany, Florida, Parma, Italy, more Canadian, Wales, Texas, Woodlands, and welcome. We are talking about the Comet E3 or C2022, E3 ZTF, and hello from Italy to Sylvie. So we know where they come from. Some of them come to visit us. So what do they look like? I think we're going to show the slide at the same time you're talking.
Sure, yeah. So comets start out far away, right? Super far away in this Kuiper belt, or farther away in the Oort cloud, where it's super cold and they can hold a lot of ice. And when they're there, they just kind of look like an asteroid. They're not doing anything crazy. They don't look like this. They don't have a tail yet, and they don't have a coma. But once they start to get closer to the sun, they get warmer. And the ice sublimates, like I was saying earlier. It turns into a gas. And once that happens, that gas lifts off and it brings dust with it. And that's what forms these tails that you know about comets. And so that's what you see here. You see all of this fuzziness around Comet E3. That's this dust and gas. And what you usually get, especially as a comet gets closer and is experiencing that interaction from the heat even more, is two tails. You get a dusty tail mixed with gases, which is this sort of fanned out part of the tail that you see here. And you also get a tail of just ionized gases. So the gas interacts with the sunlight and ionizes. The particles that are ionized are very small. And so it's very easy for solar radiation pressure to just push it. And so you get this skinny stream of ions coming out of it, and that's the ion tail. So those are the two tails of comets. So this is what they look like. They kind of vary what they look like depending on the viewing geometry. Mm-hmm. So depending on where the Earth is and where the comet is and where the sun is. This one picture in particular I chose because I think it's interesting. It has this really flat looking fanned out tail. It almost looks like it has two dust tails, one going towards the ion gas and one going the other way. But it's actually one tail, and it's just our viewing geometry. It's almost like you're looking at it head on, and there's a big cone of dust behind it, and you kind of see it peeking out, like if my hair was like this.
Okay. Oh yeah, now I understand.
Now you get it. Yeah.
Now I'm getting it.
As opposed to this.
Yes. Okay. That's why when you study comets, you need to have long hair.
Yes.
Because that's the only way you can understand the image.
Yeah. Right? Like, I don't get it yet. Let me test.
Yeah. I will not be able to do that. So, all right. We have more viewers coming to join us here. We have Bruno Guillet. Hey, Bruno. Hello from Bruno is from France. We have some people from Sweden. More Californian, more Swedish, from everywhere, Vancouver as well, from Puglia, Canada. I mean, this is an interesting topic, apparently. We have a lot of viewers right now. People are excited about this comet. So tell us why. Why do we care about this comet specifically?
Well, one reason is that it's close by, right? So we're just excited that we can see it so bright and so well. I have to say, this comet isn't special or rare as far as comets go, but it is rare in that we're only going to see this comet one time. And we don't often get to see them this close. Maybe once every other year we get to see a comet that gets as bright as this because it's so close. So that's what makes it special. And so we can learn a lot more details than we can normally when we study other comets that, when we look through them, look through a telescope at them, we usually just see a dot that's fuzzy and we can see the tail, but it's hard to really pick out the features of it. But here we really can. And so we can look at the various aspects about it, the way the dust looks, the morphology of it. We can study the gases specifically that make up the comet a lot more closely. So that makes this very special. And every comet is a little bit different. None of them look exactly the same. None of them act exactly the same. Sometimes some sublimate a lot more than others. And so if we only get one chance to look at this comet, we really got to try to understand it and find out, really, is it different from the others, or is it what we expect? Do we not know something about comets that we need to learn still? And are we going to find something surprising or not? So far, it's been pretty much like the other comets we know, as far as the gas that it's letting off and how much gas it's letting off, which is good because, we have this idea of what comets are, and this is confirming it. So that's very good.
So there is a lot of noise about the fact that it's a green comet.
Yes.
So is that special?
It's not special. It's cool, definitely. It means it's giving off a lot of gas, and that gas interacts with the sunlight and appears green in our eyes. But this is very typical for comets to have these gases that look green to us. It's going around on the internet that a rare green comet is coming just once in our lifetime, which is true. We talked about why it's rare and why it's green, but it's not rare that it is green. And I do want to emphasize that.
Okay.
Yeah.
Yeah, that's important. Daniel Fisher asked us on Twitter why we put in the title the rare comet. Well, it's a rare comet because it's also a comet that you could see with naked eye. And it's a comet that, because it's close to us and still extremely active. Mm-hmm. That's a combination of parameters. Yeah. Right?
Yeah, definitely.
So let's talk about this because we have a lot of questions about that. Observation. Okay. So how can you observe this comet?
You can observe it several ways now. So obviously with the telescope, you can see it very easily right now with binoculars, and it's been able to be seen with binoculars for a few weeks now, and even naked eye. So it's kind of on this edge of brightness where it's a bit hard to see with the naked eye, but you can. People have reported being able to see it in really dark skies. You got to go outside and really let your eyes adjust before you try to see it to the darkness, and that can take like 20 minutes. It helps to look up where it is. The comet is moving, especially in relation to the stars. So every night is going to be somewhere different. Mm-hmm. So you want to look up when you go out tonight, what constellation is it in? It's very easy to find a sky map that pinpoints where the comet is. And then go and either bring a telescope or binoculars to find it the first time. And then once you know where it is, you probably will be able to see a faint little fuzzy dot in the sky. And it's going to be a little bit hard to see. The comet has a tail and a coma. It's fuzzy. So there is a lot of brightness coming from it, but it is kind of spread out. So a comet of this brightness might look a little fainter than a star of this brightness, which has all of its brightness concentrated into a pinpoint, whereas the comet's a little more fuzzy and spread out. But my other tip is when you're looking for it, if you're still having trouble seeing it, try using averted vision, which basically is where you look just away from it. So instead of looking directly at it, you move your eyes to look, just to the left or the right or above or below it. And that actually really helps with the way our eyes are.
Because per design, we see better.
Yeah.
We are more sensitive on the side than in front.
Right.
Yes.
Because of our rods and cones and whatever, however the eye works.
Because evolution make that it's useful to be able to see the danger coming on the back.
Oh, that's a good point. Yeah. So use your survival instincts to view this comet for sure.
I'm going to quote you on this one. Okay. What about if you have a telescope?
If you have a telescope, it'll be very easy to see. It's very bright. You just will have to look up the coordinates. So again, the comet is moving. So make sure when you're looking up coordinates, that you're looking up the coordinates at the time that you want to view it.
So we have pictures here taken with telescopes. Those are pictures taken with the unistellar EV scope.
Yeah, all of these are EV scope.
So maybe you could explain that before we go through the pictures.
Yeah, sure. So the unistellar EV scopes basically are these small telescopes that are really easy to use. There it is.
Yeah.
So it's a small telescope. The aperture is about 4.5 inches. And basically, a lot of people have these telescopes worldwide. And so we can use everybody's observations and study this comet. But it's very easy to see. They just point. These pictures are all taken over the course of a few minutes, not long exposures at all.
And so with this small telescope, you can see the coma, you can see the tail, you see the greenish color here on near the coma, and you can see some changes overnight. I've been observing the last 3 nights was clear at the beginning of the night, and you just need to be sure you see if you see the Polaris, the northern star from the northern hemisphere, you're almost certain you will see this comet because it's very close. And you can see just in a few days how it changed shapes and color as well. So that was pretty cool. One parameter which is important when you observe a comet is also the presence of the moon.
Yes.
So right now we are going to full moons.
Yeah.
So it's not going to be the best condition, right?
It's unfortunately bad timing as far as the moon goes. The moon is bright and it's getting brighter. And of course, that's when Comet E3 is closest to us. But that does make things harder. Definitely think about that when you're going to look at it.
Okay, so we do scientific studies with that. We're not just only looking at the comets, right?
Yes.
So maybe you can tell us a bit what you do yourself for your study for the SETI Institute.
Definitely. And so my goal with studying comets is to monitor their activity over time. I kind of talked about before how every comet can be a little bit different. It might give off a different amount of gas. It might have a different amount of ice on its surface. And so sometimes they could be a little unpredictable. And so what we want to do is monitor their brightness over time and be able to predict how bright they're going to get and how bright they're going to fade after they go past the sun. And this is also important because comets do crazy things sometimes. Sometimes they outburst. And so while it's brightening, we think we have an idea of how it's brightening, they can suddenly outburst for various reasons. And that's where it gets much brighter, much faster than predicted. And this can happen because as the comet gets closer to the sun, it's getting hotter. It could cause a thermal stress that'll cause the surface to crack a little. And once it cracks, now a lot of ice has been revealed, and that ice is going to sublimate very fast. And so that's when you see these outburst events. But it doesn't have to be just due to heating up from the sun. Comets outburst for a few reasons. Sometimes they're just simply spinning too fast and they break apart because of that. And so sometimes we see an outburst happen far away from the sun, which is odd. And so we need to be able to catch those moments, because in order to understand why the comet is doing that, we need to catch it right away and monitor it. And that's why also I really like using the unistellar network as a tool, because we have EV scopes all over the world and a lot of them. And so every night we're looking at the comets, and if there's a change, we're going to catch it. And all the EV scopes are the same technology. And so I don't have to worry about somebody using crazy settings or a detector that I don't understand. I can very consistently monitor the comet over time and find an outburst or find out why there are no outbursts. We thought E3 might have an outburst when it got close to the sun because of the heat. And it looks like it might have had some tiny ones, but nothing crazy, So
it's still here.
It's still here. It hasn't broken apart, but that's why we got to monitor these things, because sometimes they do. And if they outburst, or if they outburst to the point where they fragment and pieces come off of them, then that comet is now losing mass really fast. And if it's doing that often, well, then we have to change what we think about the lifetime of a comet, right? It's not just losing gas to sublimation. It's now losing rocks and boulders and lots of its mass due to fragmentation of various reasons. And so we really want to understand what's the most common reason. Can we predict it if we understand the reasons?
Yeah, so the goal of people like you who study comets is really to observe as many as possible of those comets to kind of get an idea of the behavior.
Yes.
And kind of maybe classify them. This is a long period comet, come from the first time in the inner part of the solar system. It will have this kind of behavior. Or maybe this is a comet that's been coming regularly. So then we see a different color or a different activity.
Right.
And that gives us an idea of the composition of the nucleus or the distribution of material into the nucleus of the comet.
Yes.
That's pretty cool. We have questions. I'm going to go through some of them, hopefully. Let's try to get some short answers. One first question from Donald Weaver, watching from Wisconsin. Hello. Should I be able to see the comet from here?
So if you have a dark sky, yes, from Wisconsin you can. If you're in a city with a lot of light pollution, I think it'll be hard. If you have any clouds, then just forget about it. There's no way. You want a clear, dark sky, and you should be able to pick it up.
A question from RL. Hello from California, Dr. Graykowski. Do you have a favorite comet?
Oh, that's a good question. I was even thinking about this earlier because I thought somebody might ask. I think it's hard not to pick E3 because it's what I've been looking at a lot recently. I did my PhD on a different comet, a short period comet, so one that originated from the Kuiper Belt. It's called 73P. And so I've thought about that one a lot in my life. So that one's probably my favorite. This one's also really cool because it outbursts a lot in the form of fragmentation, like I was saying. So several times we've seen pieces of it just come off. And this happens to this one when it's super close to the sun, or at least closest in its orbit to the sun. So it's probably some sort of thermal effect. But I just think that's awesome. Every time it reaches perihelion, or when it's closest to the sun, everybody turns their telescopes to this comet and hope that it fragments again. So 73P.
73P. Yeah. Okay, that's the answer. What else? Yes. Can we see this comet from the southern hemisphere?
Not right now, but very soon. I think within the next week or so, it's coming to the southern hemisphere. But right now, it's circumpolar in the northern hemisphere, which is unfortunate for our southern hemisphere astronomers.
Well, I'm just gonna add, they had so many opportunities to have beautiful comets over the past 5 years.
Yeah,
For once in the northern hemisphere, we have one. I mean, come on. Thank you very much, MCatfish 2100 for the donation. We appreciate your support. Any more questions from our viewers before I go to the final question? Have you guys seen any UFO?
I have not.
That's an answer.
Yeah.
From Ariel Graykowski of the SETI Institute. She has not seen any UFO.
Yeah,
Thank you.
Not me.
Okay. I have multiple questions. Let me see. Let me see mine. So what is the next step for you in the study of comets in general, or maybe this comet specifically?
Yeah. So once we have a good idea of what's going on, we want to really make sure our photometry, our measurement of that brightness, it's called photometry, is accurate. And we will make that light curve that you saw before, and we'll work on publishing a paper about it to say, this is the activity of this comet, especially if a comet in general does something crazy. So like an outburst. When that happens, we want to understand that right away and write a paper eventually. The goal of these analyses are to get them into a paper, so that way they're in the scientific community and people can cite it and read it to understand more, so they can follow up on it and even build our knowledge even further. So that's always the goal. So that's sort of what I'm working on, afterwards, after I get the data, is really making sure this data is there for everybody and the analyses are available for everybody in the form of publications.
Yes, so I encourage the citizens astronomer of the Unistellar network to continue to observe regularly this comet, because Ariel is waiting for your data. In fact, every day she's displaying this graph. Maybe we should show this graph. Can we show this the slide again? I want to show this this figure that Ariel is looking at every day. This is what she does.
Yeah, every day. Yeah, so this one's not the most updated one, but yeah, so basically this is just a plot of brightness over time, and then I just...
So that's the time, and that's the brightness?
Yes.
So the brightness increases as the comet goes close to the sun and to us, right?
Yes,
okay,
exactly. And so we take into account, you know, how close it is to us and how close it is to the sun when we fit this plot. There's a lot of challenges in doing this kind of photometry on a comet that is so close, and on the detector takes up so much space. So that coma and that tail is really spread out. But the way I measure brightness of a comet or anything is I choose a circle to lay over it, and I measure the amount of flux or the brightness coming through that circle. If I choose a circle that's too big, I'm going to start getting the flux from stars nearby. And it's also going to become really noisy due to the sky background. So it's very difficult to choose a circle size or an aperture size to measure that flux through. And so there's always challenges there. And so we work on understanding how that brightness is tapering off. And figure out how much brightness we're missing when we choose a circle size, how much brightness is still in the tail that didn't make it into the circle, and we try to add corrections onto that. But it's a challenging thing.
Yeah. That's why you're spending the day doing this effect. Okay, let's stop sharing. I just look at the ephemeris, and the declination of the comet will be negative starting in March. So that means that mid-February, from Sydney, you should be able to see it if you are in the southern hemisphere. But it also means that it's going to get more and more negative. So this means that it's going to be in the southern hemisphere in May, June. So we will rely on observers of the unistellar network and others from the southern hemisphere to be able to monitor still the activity of this comet. It's going to be bright enough for quite a long period of time. I mean, I don't know, we can estimate all the way to June, we'll be able to observe it.
Yeah, definitely. I see a lot of jokes online like, oh, okay, that was a cool comet, what's next? And I think it's super funny, but you know, this one's going to be around for a long time. And for what I want to do, which is monitoring it for a long time, I want everyone to still look at it and still be excited about it. It still can do something like outburst. We don't know. That stress that it got from the heat, that can take a while to go through all the dust on the surface. And then it might find a pocket of ice, and that pocket of ice might expand and outburst later. That can happen, and that's happened before. So there's still a lot of exciting reasons to observe it, even just to make sure our predictions have been correct so far.
Yeah. Well, one question for Thorsten Krug. I wanted to ask this question. So how big is the comet in meter or kilometer, whatever?
The nucleus, so the part that isn't all the dust around it, just the, you know, sort of asteroid part of it, is predicted to be about a kilometer in diameter. Yeah.
Right. So it's not a big body.
No.
Typically, I mean, let's give a scale. Ceres, the largest asteroid in the Main is 1,000 kilometers.
Yeah, typical comets are like 10 kilometers.
Yeah. Hale-Bopp was 50 kilometers.
Yeah.
It was a giant.
Huge.
Yeah, it was huge.
Yeah, and that's why, because it's about as close as it was, or as a C2020 F3 or Comet Neowise. They both got about as close to Earth, but Neowise was a lot brighter and big. It's probably because it was bigger and therefore had more ice to sublimate on its surface. I do have a picture of the comparison of those two in the sky.
Can we show the slide again, please?
It should be the last slide.
The last one.
Yeah, so this is a Photoshop picture of the two. So there's Neowise on the left, is very obvious, and then little E3, green E3 on the right. So it looks very different, and that's why this one's going to be a lot harder to see.
Yeah.
Yeah.
So yeah, the activity also depends on the size of the comet. That's something important that we should mention as well. Okay, I think that's all. There is another comet coming this summer.
Yeah, I mean, there's lots of comets coming, but there's a bright one coming in the summer called T4 Lemon.
Okay.
Yeah.
And it's not going to be as bright as this one.
No, it's not predicted to be.
Okay.
But maybe that will change, so we need to observe.
Okay. More observation for you guys.
Yeah.
Okay. Well, thank you very much. Thank you, Ariel,
Yeah.
for the time. I know you're extremely busy right now, so I appreciate you took the time.
Yeah, of course.
You're welcome to come back to tell us everything about comets in the future.
Thank you.
So that was the SETI Live by the SETI Institute. We are a non-profit organization, as you know. You can follow us on our social media. We are on every platform if you want to know everything about space exploration, what's going on in the sky, etc. Follow us on social media. If you like this video, you're watching us now on YouTube or anything else, thumb up, make a comment, ask questions. We take the time to read your comments and your questions, of course. So take the time to interact with us. We are happy to hear about your thoughts on comets, on aliens, on anything you want. Okay. Write them on the comments and we take the time, okay? And if you are inclined, if you like this show, if you want to support us, you can make a small donation or a big donation. You just need to go at SETI.org, click on donate on the top right, and use your credit cards or whatever you have, cryptocurrency. I think we take that too, okay? Thank you very much again. Thanks again, Ariel.
Yeah, thank you.
Have a good day, good night, good evening, good morning, and see you soon. Bye-bye.